Now that we've talked about network masks, let's talk about how network IDs and host IDs play an important role in IP addresses. So let's bring up our previous example, the engineering subnetwork, and let's picture a host with an IP address of 192.168.1.2. The network mask for this example could very well be a /29, which would be 255.255.255.248, which is one that we haven't looked at yet. So let's go ahead and convert it into binary. Imagine the network mask as divided in two different parts. The first part contains all the binary ones, and the second part contains all the binary zeros. So the first part of the network mask is made up of all the ones, meaning the first 29 bits, and this is called the network ID. The other 3 bits, which are made up of all the zeros, is called the host ID. The host ID is what's used to determine where a network segment ends and where another begins. That means we can use it to know how many hosts we can have in a subnet. In fact, let's go ahead and take a look by looking at just the last octet of the IP address and the network mask. The ones make up the first 5 bits, so let's split this up after the 5 bits since this is where the network ID ends and the host ID begins. And let's focus only on this part for a bit. Since we only have 3 bits on the host ID, this means that on the IP address, only these bits can be turned into ones and or zeros, while the other bits are already set in stone. Let's start by turning all of the bits in the host ID part into all zeros. This would make the IP address be 192.168.10 with a mask of 255, 255, 255, and 248. But now let's turn on the first bit by converting decimal value 1 into its binary number, which also happens to just be 1. And we can verify that if we want to with a decimal to binary converter calculator. Now this gives the IP address 192.168.1.1 with the same mask. Let's do this until we have 7 for our last octet, and you'll see why 7 in just a second. So this is what it would look like. Now let's look a little bit closer to when we have 7 as the last octet. As you can see, when we are at 7, we've turned all of the bits into ones that correspond to the host ID. When we've turned all the host bits into ones, this means that we've reached the last IP for this network segment. There are no more bits that we can turn into ones, so we have no more IPs that we can use in this network segment. So this means that this network segment is formed by 8 different IP addresses, starting with 192.168.1.0, then .1, .2, .3, .4, .5, .6, and .7. However, there's a few more things we need to know. The first address, when we have all the host bits set to 0, is what's called a network address, so that one is not assigned to any host. Neither is the last address, which is the one where all the host bits are all set to 1. That one is called a broadcast address. This means that the first and last addresses are reserved and they can't be used for any hosts. So we really only have 6 addresses that are available in this subnet, and they are 0.1, 0.2, 0.3, 0.4, 0.5, and 0.6. On top of that, one address is assigned to the router's interface. So that's why in our engineering subnetwork example, we had a router interface with an IP address of 192.168.1.1. As a best practice, usually either the first or the last of the available addresses are assigned to the router's interface. So again, this means that we effectively only have 5 addresses that are available for hosts with this configuration, being 0.2, 0.3, 0.4, 0.5, and 0.6. So what happens when you need more hosts, right? That's really not that many hosts. Most homes and most corporations would require far more than that. Well, you can fix that by adding more available bits to the host ID part. So let's look at my network configuration that was shown before, and let's look at the network mask. As you can see, I have the complete 4th octet available as a host ID. This means that my complete subnet address is, in this case, 192.168.0.0/24, and it goes from 192.168.0.0 with all zeros in that last octet, all the way to 192.168.0.255, which is all ones in that last octet. So that's a total of 256 IPs. But as we said before, the first and last IP addresses cannot be used. We also need to use one for the router's interface. So we really only have 256 minus 3, which equals to 253 IPs that are available for hosts. So that's still a lot of hosts, at least relatively speaking, and that's why home routers usually have a /24 mask configured by default. But that's for home routers. What about enterprises that require far more connected hosts? Well, you assign even more host bits. For example, let's take a look at 192.168.0.0/16. With /16, we have 2 entire octets that we can assign hosts to. We can go 192.168.0.0.0.1.0.2, etc., all the way to .255. And once we're there, we can go 192.168.1.0.1.2, and so on, all the way to .255.0. But even then, you can still go .255.1, .2, .3, etc., all the way to .255.255. At that point, then you'll have turned all the host bits into ones, which means you've run out of hosts. But if you do the math, you'll see that this will give you more than 65,000 available hosts, and that's quite a lot. Now, as a real-world example, let's say that you are a leading network engineer creating an IP plan for a company with several locations. You take that huge block of IPs and you divide it, which is what we've been called subnetting. For example, you can divide the previous IP block into several /24s. So you might have an office in California that has a 192.168.0.0/24, which would give you a range of 192.168.0.0, again, all the way to 255. But then maybe you also have an office in Texas, in which case you use 192.168.1.0 with /24. So you get the same thing, but in this case, it's 192.168.1.0 all the way to .1.255. And then same thing for New York, where you have .2.0/24. So you can use a range of .2.0 all the way to .2.255. But the cool thing is, you can still further subnet each one of those into smaller chunks of IPs. So if we zoom into California specifically, maybe you have 3 different departments in California and you want to segment those. So the sales department will use the IP and mask of 192.168.0.0/29, which gives them a range of .0.0 all the way to .0.7. Then you can have a different one for engineering at .0.8/29, which would give a range of .0.8 all the way to .0.15. And then one more for the marketing department at .0.16/29, which would give you .0.16 all the way to .0.23. Now don't worry, this can take some time to wrap your head around, especially if you're not mathematically inclined like me. So if you're having a hard time following along, try going through the last couple of lessons a few more times, since you'll probably pick up some additional details that you might have missed the first time around. And then feel free to reach out in our forums at cyber.com/forums or on Discord at cyber.com/discord, and we'll be more than happy to help. This is an important concept to understand in networking, so we want to make sure that you understand it. But otherwise, go ahead and complete this lesson, and I'll see you in the next.